Supplemental math videos from Circle Christian School.
Geometric mean. This is where you look for the twins. Geometric mean is just a little bit different than arithmetic mean, which is finding the average of something. It has a proportionality to it, that is, a similarity. Therefore, there's a ratio, equals ratio. And when a fraction equals a fraction, we cross multiply. Looking at a right triangle within a right triangle. Actually, we have 3 right triangles. There's a small one, a medium, and a large. And the 3 are actually similar. In class, what we did is we took that index card and we cut it up into 3 right triangles. And because of the parallel lines and transversals, we saw that all the angles were congruent. With things that are similar, angles must be congruent and the sides must be proportional. So I'm going to take a look at just one example here that happens. I'm going to use a small triangle and then a larger triangle, which means I can compare something smaller to something larger. That could be small to medium, small to large, medium to large. I'm going to take a look at the lines AD. Let me get a color here. Okay, so A to D here, which is a side of the medium triangle, has a relationship to AC. Okay, which is going to be the hypotenuse of AC. So we're totally looking at this medium triangle. So we need something larger, and the larger one is going to be the biggest triangle that's in there. What I like to do in this proportionality, and the template is very important here, is you always identify the 2 objects that you're comparing. And then you're doing a part. And in this case, I like to stay fairly consistent with a smaller part and a larger part that matches the smaller part and the larger part of the other triangle or whatever you're comparing in 2 shapes that are similar. Not only does this go with triangles, but sometimes you get shapes like a tree to a tree or a flagpole to a larger flagpole. And from that, there's always some sort of right triangle, and you're able to match the proportionalities. Okay, small, AD. And I'm going to do this to the large one, so I need a large side, the largest side of the big triangle, which is going to be AC. And then we need the hypotenuse, because that's what we matched it to on the small one. The small one went to a hypotenuse, and the hypotenuse of the larger one is across from the 90-degree angle is going to be AB. Now we have our comparisons. Ratio equals ratio, fraction equals fraction. We're able to do our math, which is going to be cross multiplying. The next thing that I want you to notice here is that there's always going to be some sort of twins, whether it's numbers or a variable. And they're going to cross multiply, which means they're going to end up being squared. That's the difference between geometric mean and arithmetic mean. Geometric always is dealing with some sort of multiplication type of thing. So in our setup for our math, we would have AD times whatever AB is, and it would equal AC squared. The 2 ways that geometric mean usually gets used is in a right triangle that has right triangles inside of right triangles. Is the first way is when we have to find an altitude, or the setup here has something to do with the altitude. In this case, and the altitude, just a reminder, The altitude is the height of a triangle. How high is it? So for instance, if we have to find the area, remember it's always the 1/2 the base. So A to B, 1/2 of A to B times the height, which is going to be C to D. All right, now what's neat about the altitude is it makes this kind of perpendicular formation here that you're going to go from A to D to the height, which is C to D. And then you're going to go from the altitude C to D to D to B. Okay, so what we're basically doing here is doing a little travel path. Like so. And notice how that makes that little T formation here. I'll kind of dot it out. That little perpendicular thing. So we're going to go from 8 to X and X to 5. Now I just noticed on this particular triangle, just because of the way it is formed with the large side or the medium side here on the left hand side and the smaller one, you're still kind of matching up little proportionalities that happen here. And so we're going to, again, cross multiply. We always have something squared. So we have x squared equals 40. And so x is going to equal the square root of 40, which ends up being 2 square root 10. Which of course you could actually do as a calculator evaluation, but I like keeping to the radicals here. Now sometimes, as mentioned before, just to keep our proportionalities in a sight type of way, we're still looking at things that are apples to apples and oranges to oranges. That a triangle may present itself. Like I said, sometimes the triangle can be horizontally flipped here, so that maybe I should kind of show that if I can find my pen. There we go. That it's possible that the short side's here and the long side's over here. But if you just kind of consistently follow this little flow of reading left to right here, following that perpendicular shape here, left to right, you'll still be correct because we're going large to large and small to small. The other one that uses a geometric mean with triangles within a triangle is when we do not have an altitude. A lot of outside things. And in this case, we're going to do the same setup. There's always a smaller triangle to a larger triangle, and then the parts. But with this, if you consistently use a hypotenuse leg, much like one of our triangle congruencies, so I just kept it as hypotenuse, leg. You could go leg, hypotenuse, and leg, hypotenuse, much like we did on the other triangle. It's the apples to apples and oranges to oranges. And when I say apples to apples, I'm going, here's the apple, and here's the apple, and here's the orange, and then, of course, likewise, orange on the other side. Oops. Did I? Oh, look at that. I didn't spell orange right. What do I got to switch? I don't know. These three guys. Figure it out. You can have fun with that. Okay, so that's what I'm going to do. I'm going to take a look at the smaller triangle. I'm going to do the hypotenuse first, which is going to be 27. Then I'm going to do the leg, which is 16. And then I'm going to do the hypotenuse of the larger triangle here, which is going to be Z. And then I'm going to do the, and the smaller triangle, notice we use the small leg here, the 16, small leg. I need to use the small leg of the larger triangle, which is going to be 27. And hallelujah, we've got our twins across from each other, the 27 and the 27, an apple to an orange. So we end up with 27 squared, or 27 times 27, equals 16Z. All right, 27 is kind of a big number, so we'll allow a calculator on that one. And it's 729. Equals to 16Z. And using our algebra, we're just going to divide out the 16, which gives us 45 point. And I'm going to leave it at 56. I like going to two places generally when we've got rather large decimals here. Okay, so Z here is 45.56. Now the very adventurous person would be able to actually try this amongst the medium triangle and find all the other parts. And then using the Pythagorean theorem, you'd see it's true. And I know that because I actually did try to make sure all the numbers worked. All right, from the previous triangle, what we're going to do now is, because we've got at least two sides going on here, and we can produce another third side for the other triangle, so we can go find x and y using the Pythagorean theorem. All right, so I'm going to start with the small triangle here because it has two sides. And we're going to set that up as y squared plus 16 squared equals to 27 squared. Be careful to make sure that you've got sides a squared plus b squared, and that the hypotenuse is at the end. Remember, the hypotenuse is always across from the right angle. So now we have y squared equals the 729 minus the 256. And so square rooting both sides, we see that we have, hold on here, 729 minus 256 is 473. Second square root 473 is 21.7. And we see that that makes sense. We talked about this in class, making sense that our two legs are a smaller value than our hypotenuse, the 27 here. All right, so now we're going to go find x because we have two sides again. And this time we're looking for a hypotenuse because the x is across from the right angle. So we're going to take the 21.7 and square it, plus the 29.56 and square it, and it of course is going to equal our hypotenuse here. Okay, so we end up with 13, oops, that wasn't the right place, 1344 point, what do I want, 68 equals our x squared. So I'm going to square root both sides. So x is going to equal 36.7. And there you go. And again, it makes sense because it's larger than the two legs. So by using things like geometric mean, trigonometry, special angles, we can always find all of our sides as long as we get to a place where we have two sides and we can use the Pythagorean theorem. Remember, everything, absolutely everything, goes back to a right triangle.